have here is this is a schematic of my version of the Softkey for the SB-200 HeathKit linear amp, and this is just my version. And I built it off this breadboard like this and took it through the stages. And so when I got the schematic done, I done a PCB layout of the board, and I took it through 4 stages of development. And the 4th stage is the finished product here. Okay, now this LED here means power good for 12 volts. That's a regulator. Now I'm going to demo this thing. It's a power supply. Okay, now I've got this hooked up to the back of the radio, and I found the appropriate key with the oscilloscope. So when you push to talk, you get this LED, and that means transmit. And I got a dummy load on here, so it's doing okay. And there's my dummy load right there. I made that myself too. But yeah. Now what's going to happen is on the SB-200, when you take that RCA jack, the center pin, and ground it, it'll turn that relay on. So it's gonna connect here. So you'll connect it here, and you'll come out of this and go to that 33 ohm resistor that's between here and the relay, the transmit receive relay. And we got an optocoupler here. Just but that's my design there. And I done a silk screen on this board, as you can see. That resistor there is that 15K that's on the board or on the amp. I took it off the amp. I'm going to mount it here. And there's a HeathKit Softkey. Softkey interface by, that's my call sign right there. So yeah, and I'm going to put this in there, and I'm quite sure it's going to work. This is a 110 volts here. This is a 12 volt transformer, bridge rectifier, all your basic stuff. There's the diode, and then there's a resistor there. It keeps 12 volts from burning out this LED. Okay. Now, I'll show you. There's the machine I done it on. That's an LPKF, but it's the LPKF machine. The electronics is something that I built, put in the bottom there, because the board was no good. And this is what I use to run the machine with. This is a logic analyzer. None of this is functional for the machine, but this is still functional for a logic analyzer. It's got parallel port on the back, and this runs off XP, Windows XP. Okay, let's move on up here. Okay, now this silk screen, as you can see, this silk screen here, I made this. The way I made it is this is water transfer film. You can get it on eBay. Water slide decal paper. There it is. Water slide decal paper. You print the silk screen on there, and you cut the silk screen just a little bit smaller than the board. See that inner line there? And a little bit smaller than the board. Then you position it. After you wet it, you can slide it right off on here. You wet the board first, slide it off on there and position it. Once it dries, about a couple of hours, then there's another thing here. You spray it with this, 2 coats of this. It's shellac, and it's clear, and it dries fast. And I got that at Ace Hardware. Okay, and once it dries, it dries fast. I just leave mine set overnight, and it's smooth. Got a hard finish to it. It's got a real hard finish to it. It is durable. Okay. Well, I guess that's about it. But that's how I done the board. This is the SB-200. Put the power supply in there. But that board, I'm going to mount it right here. I'm going to mount it right there. And that's that resistor right there that I was talking about. And it goes, yellow line, it goes all the way up here. And it goes right here. It goes right here on the relay. Yeah. But that's it. I've cleaned all these wafer switches. I call them blade switches. I cleaned all those with Tarnex front and back. And then the one inside here, I cleaned all it front and back. You can remove these. I removed them and pull the switch off and cleaned the front of it. See how it's clean? And then on the back, I done the same thing. And this relay here, someone else put it in there, but I'm taking that out because the one I'm using instead of that, it's on that board. Okay. That's about it. I'm going to put the power supply in it here next. Alright. That's it.